When talking about quadratics and the quadratic formula, you need to talk about the part that's called the discriminant, and that's what this is about. And basically, is there a shortcut to help you find if there is a solution? There is, and that's what we use the discriminant for, to help us to determine numbers of solutions. I have a little bit of math humor for you today. Parent says, "What did you learn in school today?" Student said, "We learned about negative discriminants." It was unreal. Well, I'm going to explain why negative discriminants are unreal in a few moments. But let's take a look and remind ourselves some things about quadratic expressions and quadratic equations. First of all, we must remember that when we're in standard form and we have it equal to 0, that there has two possible, I said two answers here, but two possible answers, and we call those possible answers roots. And we got to remember that the reason that is because this is a second degree polynomial, and that 2 right there also helps to lend us to that idea. Now, if we can think about the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, you should recognize that this is made up of two parts. This part right here is the axis of symmetry. If you can remember that, then we can do the basis of the rest of what we're looking at. With the axis of symmetry, that tells us where exactly that parabola is going to be centered. And what the discriminant does, which is this part here, is going to tell us how far away we are from each side. So, with that discriminant will also tell us, if we just evaluate it and not really look at its true value, but look at it, it will tell us how many solutions there are to an equation, the number of x-intercepts that are available or will occur, and the number of roots. And we have to recognize that all of those are the exact same thing. Regardless of what's being asked, they're all the same thing. So let's see if we can put together a table and be able to put some descriptors to this so that we're able to use it to our advantage. So here I have a little bit of a chart. I have the value of the discriminant, and there are three possible values for it. It could be a positive number, it could be 0, or it could be a negative number. And based on this information, we'll be able to tell how many solutions it has or how many number of x-intercepts it has. We have to remember that these two things are exactly the same thing. We can also say how many roots it has. This would also end up being the exact same thing as the number of intercepts or the number of solutions. So we keep that in mind. Well, let's start with an example of what something would look like, and then we'll go from there. So let's say that if we got the square root of 16. Now, the square root of 16, we know that the primary square root is 4, but also that it's negative 4. And when we use that in the quadratic formula, because we're using plus or minus the square root of a number, that means that we're going to get two possible solutions. Well, that will put the 2 there. And also, since two possible solutions means that we could have two x-intercepts or two roots of that quadratic equation. When we take a look at 0, so the square root of 0, we take a look at 0, we know the square root of 0 is just equal to 0. Just one answer and one answer only. When you think about it back into the quadratic equation again, we're talking plus or minus the square root of 0. Well, when we're doing that, are we really affecting it? We're not. Which means we're only affecting, the only thing that's going to be there is the axis of symmetry, nothing else. So the solution, or the number of x-intercepts, is going to be 1 at the axis of symmetry, at the vertex. And same thing with the number of solutions here, it's going to give us 1. Now, what do these things look like? Well, if I was to draw a quick little picture here of a coordinate plane, we would get two solutions. This would show how to. When we're looking at one solution, it's going to be sitting right on the axis, just giving us one solution only. Now let's talk about negative numbers. As an example, let me give you negative 4. Now we can't in the real world take the solution to square root of negative 4. We would say at this point that that was impossible, that there was no real solution to this. And that's true. There is no real solution to this. But once you start to understand ideas about square roots and cube roots, and it takes us a little bit more into algebra 2 and different number sets, we know that that actually is equal to 2i. I comes from the imaginary number system. And you'll learn more about that in algebra 2. But that does have a solution, but not in the real world. And since we're dealing with the real world, we say it has no real solution. So that means that there will be no solutions, no x-intercepts. And what does that look like? Well, if we were to graph this parabola, it might be something like this, where it never, ever, ever runs into the x-axis. So we would not be able to come up with a solution. So let's practice here a little bit. Here I have a quadratic, 4x squared minus 7x plus 2 equals 0. And let's find out what the a, the b, and the c is. Well, the a is 4, the b is negative 7, and the c is 2. If we take this information and put it into b squared minus 4ac, we can determine what's going to happen. So here, if I take and turn and plug in what I know, I'll have negative 7 and have it squared minus 4 times a, which is 4, times c, which is 2. Well, this would be 49 minus 16 times 2 is 32. 49 minus 32, that's going to be 17. Well, since 17 is a positive number, that means that this particular quadratic will have two solutions, or will be crossing in two places on the x-axis. Let's take a look at another one here. Here I have x squared plus 5x equals negative 8. What we'll do here is first we need to get everything to the same side. So let's add 8 to both sides. And that will give us x squared plus 5x plus 8 equals to 0. Now based on this, again, we're going to get our a and our b and our c. So a is 1, b is 5, and c equals 8. Now we're going to take that and put it into our b squared minus 4ac, which is our discriminant. So that will give us 5 squared minus 4 times 1 times 8. 5 squared is 25, minus 4 times 1 is 4, times 8 is 32. We reduce this down, we'll get negative 7. Well, since we cannot take the square root of negative 7, this particular quadratic will have no real solutions. Again, this is something that is not touching the x-axis. It does not have any roots to it. Let's take a look at one more. Here I have the function of x equals x squared minus 12x plus 36. Now, we might be confused by the function notation, but don't. Remember to think about what are we trying to do? What does it equal? Where are we headed? If we're trying to find out where that parabola is hitting the x-axis, what we want is we want y to equal 0. In other words, it's a function of x. We want y to equal 0. So really we're looking at 0 equals x squared minus 12x plus 36. And this will help lead us towards getting our definition of our discriminant. So in looking at this, we know that a equals 1, b equals negative 12, and c equals 36. And again, we're going to put it into this b squared minus 4ac notion. So negative 12 times 12, negative 12 times 12, so 12 squared. 4 times a is 1, and c is 36. Well, negative 12 times 12 is 144. Bring down the negative sign. 4 times 1 times 36 is also 144. So our answer is 0. If we know it's 0, that means we're going to end up with one real solution. Now, where does this come from, one real solution? Let me see if I can kind of prove it over here on the side to you. If I took the quadratic x squared minus 12x plus 36 equals 0, and I regrouped it using factoring, so put positive 36 and negative 12, we know that this would be negative 6 and negative 6. I'm going to regroup this middle term using that. So that's going to give me x squared minus 6x plus 36 equals 0. Cut it in half and take out the greatest common factor, which is x. Leaves behind x minus 6, and using that as a common factor on the other side, that would give me negative 6 as well. And when I pull out the greatest common factor there, leaving behind the other factors, I have identical binomials, x minus 6 times x minus 6. Some people might have recognized this as a perfect trinomial square. If I was to factor this, I only need to factor one of them, and adding 6 to both sides, I would find out that the answer is 6. Indeed, it only had one solution. This is going to be a quadratic. It's going to be sitting at positive 6, going up, and that would be my one solution. So you can see how it works and where we can find out what your solution actually is. Hopefully this will help on how to use the discriminant.